You know, I've skipped a couple of sections as I've gone on to section 6 of chapter 13, exponential and logarithmic equations. And I just want you to know that those two sections involved, first of all, mostly finding common logs using your calculator. So, you know, find the log of 1,000 on your calculator. And so you hit the log key and type in 1,000 and you get an answer of 3 because a common log has a base of 10 and 10 has to be raised to the third power to get 1,000. So they might ask you to find the log of 2,356. And since the log of 1,000 is 3 and the log of 10,000 is 4, I know your answer should be 3 point something. So I hit the log key of 2356 and I get 3.372. So essentially that's section 4. And section 5 is a little bit of work with natural logarithms. And we use the ln key for a natural logarithm. It means log where the base is e, which is the number 2.7. And we don't have time to go into where that number came from. We did go into where pi came from, which was 3.14. But anyway, to find the natural log of 5, for example, you just hit the ln key and then the number 5, and you'd get 1.609. This is because e, the number 2.71, e to the 1.609 power would be equal to 5. If you look above your division key on your calculator, in the upper left corner is a little e. So if you went second and then e and then a caret key and 1.609, you'd get the number 5. Also, above the ln key on your calculator is an e to the x key. So if you just went second and then ln key, you would have e2 already on your calculator, and you could put in 1.609 and it would give you the answer of 5. So anyway, section 4 and section 5 are about common logarithms and natural logarithms, and we always run out of time before we can before the end of our class occurs. And so what I'd like to do now is I'd like to solve exponential and logarithmic equations. So, you know, we're going to start with exponential equations. We're going to solve them. And while this is pretty easy to put into logarithmic form, so to take this exponential statement, and remember, a logarithm is an exponent, so I could get x all by itself because a logarithm is an exponent. And remember, the base here is a 3 of 1 over 81. So the only thing is, you know, how do I type this on my calculator? Well, let's go over here and you can see how to type it a little bit easier if you use these steps right here. Step number 1, take the logarithm of both sides, either the common or the natural logarithm. So I'm going to use red here so you can just see it. I'm going to take the log right here and I'm going to put the word log right here of both sides. Then, see this x right here? I'm going to bring it down in front. So I have 3 times the log, I'm sorry, it should be an x in front here. X times the log of 3 equals, and on the right side I have the log of 1 over 81. Now to solve for x, it's x times that log of 3. I'm going to divide by the log of 3. Well, this is the change of base theorem. This is gone now, and x is all by itself, and it would be found by you typing on your calculator the log of 1 divided by 81, close your parentheses, then the division sign, and then log of open parentheses, close parentheses for 3, and then hit enter. And you know, I'm afraid I forgot to do that, so I'm going to do that real quick. The log of 1 divided by 81, and then divide that by the log of 3, and I get an answer of x is equal to a negative 4. Well, of course x is equal to a negative 4 because 3 would have to be raised to a negative 4 power to get 1 over 3 to the 4th, which is 1 over 81. Okay, let's do this next one. Again, remember, you could just go ahead and put it in logarithmic form. So the exponent would be all by itself. The base would be this e of 1,000. So all you have to do is type on your calculator the natural log of 1,000 because log base e means this ln key. And when you do that, you get 6.91. So the answer is 6.91. Also, you could check that answer, don't forget. You could take e and raise it to the 6.91 power on your calculator and check it and see if it equals 1,000. Now, because I'm going to have to use this skill elsewhere, I want to remind you that up above this said take the log of both sides, then use the power rule for exponents, then divide both sides by the coefficient of the variable to isolate the variable, and find an answer in decimal form. So I do want you to know that when you take the log of both sides, you could take the ln of both sides here. And then see this t? I'd bring that down in front, and I'd have t times the ln of e, where the base is e, equals the ln of 1,000. Remember, the log of something where the base is the same, this is always equal to 1, so I don't need to get rid of it because that means this is 1 times t, which is t. And it tells me, therefore, to take the natural log of 1,000, just like we did, to get the answer for this problem. Number 3. What I'm going to do is, and I'm doing this in red so that you can see it, I'm going to take the log of both sides. So this will be the log of 27 on the right side. And that 5 minus x is going to come down in front. So I have 5 minus x times the log of 3 equals the log of 27. To isolate x, I'm going to get rid of the log of 3. So I'm going to divide both sides by the log of 3. And so on the left side, I'll have 5 minus x equals. If you type the log of 27, open and close parentheses, then divide, and then by the log of 3, open and close parentheses, and then hit enter, you would get an answer of 3. And that's because this is saying 3 raised to what power gives you 27? And that would be this value of 3. So now I'm going to solve for x, so I'm going to subtract 5 from both sides. So be careful, I have a negative x here. So a negative x equals a negative 2. I'll multiply both sides by a negative 1 or divide both sides by a negative 1, and I'll get x equals a positive 2. And my check would be, in the original problem, I have 3 to the 5 minus x, but x is 2. 5 minus 2 is 3. So 3 to the 3rd equals, the problem was 27, and yes, that is a true statement. There are trickier ways to get at these, but the best way is to take the log of both sides. So here, the log of 5 to the x power equals the log of 3 to the x plus 1 power. Use the power rule. Bring this down in front. So you have x times the log of 5. And over here you have x plus 1 times the log of 3. So now you're either going to divide by the log of 5 or divide by the log of 3. I will tell you that it's easier to get this alone by dividing by the log of 3 so that the right side becomes just x plus 1. And then this left side will just have a decimal number in front of x. So take your calculator and take log 5 and divide it by log 3. And you should get 1.465. Don't forget there's an x here. Equals, and on the right side, x plus 1. So we have 1.465 equals 1x plus 1. Remember, this is a 1x. So, and this is, I'm sorry, this had an x with it. So when we subtract 1x from both sides of this equation, when we subtract 1x right here from 1.465x, we get 0.465x equals this 1 right here. And now we divide both sides by 0.465, and 1 divided by 0.465 is equal to 2.15, and my check in this problem would be to take 5 and carry it to the 2.15 power versus 3 and carry it to the 3.15 power, 2.15 plus 1. So 3 to the 3.15 should give you the same answer as 5 to the 2.15. If those give you the same results, then this checks. I want to show you a trick. You see this 25? It could be thought of as 5 squared because this is a base of 5. So shoot, if I could get these both with bases of 5s, then their exponents have to be equal. So the 2x minus 3 has to equal the 2 on the right side, and I'll add 3 to both sides, and I'll have 2x equals 5. And then finally I'll divide by 2, and I get an answer of 5/2, or 2.5. You know, I was just lucky there. That doesn't happen very often, but it is something that you can look for when solving exponential equations. We better pause. This is getting a little bit long. We'll come finish, do a few more, and then we'll solve logarithmic equations.